Step into the Coliseum, everyone. Welcome to the arena where only the most prepared survive. Today's explainer isn't just a casual review. We are tackling a massive pain point for thousands of Cambridge computer science students. We're taking the notoriously tricky topic of binary addition and overflow, something that often feels like a purely theoretical math problem, and we are going to transform that rote binary knowledge into an absolute maximum mark generator for your Cambridge 0478 syllabus, as well as the 0417, 2210, and 9618 papers. You see, I constantly see two types of students entering this arena. First, we have Alex. Alex overloads his answers with raw computer science facts, dumping everything he knows about 8-bit registers but provides absolutely zero analysis. Then we have Sam. Sam rushes the paper, completely misses the specific command word requirements, and writes a vague summary. Both of them walk out feeling confident, and both of them get hit with a sea of red pen marks on results day. If you've ever felt like you knew exactly how to do the binary math, but somehow still bled points on the actual exam question, you are in exactly the right place. We are going to crack the examiner's code today and build a strategy that works every single time. Here is your roadmap to survival. We'll start by deconstructing the binary overflow trap. Then we'll move into mastering the method marks. After that, we'll cover the golden rule of Cambridge exams, context over memorization. Finally, we'll review the most critical principal examiner warnings, and I'll leave you with a foolproof 4-prompt checklist. Think of this as your personal battle plan.
Let's kick things off with Section 1, the binary overflow trap. This is where we see exactly why simply knowing the math isn't enough to survive the examiner's red pen.
I want to validate a struggle so many of you face right now. You sit in the exam hall, you do the binary math perfectly, you successfully calculate the overflow, you write it down, and you still only score one single mark out of a possible 4 or 5. Why does this happen? Because of this direct, recurring warning from principal examiners: generic responses rarely gain full marks. The ultimate trap is memorizing isolated facts. Take our student Alex, for example. Alex just wrote an overflow is when an extra bit doesn't fit in the register. Now that is technically true, but it is a highly generic response. Examiners don't want a dictionary definition. They want to see you analyze the specific digital scenario they've handed you on that specific day. When you give a generic answer, you're essentially telling the examiner you've memorized a flashcard, not that you understand computer science.
So the absolutely crucial point you need to internalize right now is that binary addition sits inside a much larger chain of ideas. It is not just numbers floating in a void. It solves a specific digital problem. Top marks aren't awarded just for doing the binary math correctly. They are awarded for explaining the process clearly using precise terminology, and most importantly, connecting that process back to the practical consequence. What does the overflow error actually mean for the user in the prompt? Does the smartphone app crash? Does the embedded system in a medical device fail? You have to link the theory to the real-world outcome. That brings us to Section 2, mastering the method marks. We need a disciplined, technical methodology that examiners are actually looking for. Before we continue and dive into this exact framework, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at the framework that top students use to structure their computer science answers and dominate the assessment objectives. If the trap is generic definitions, this 4-step sequence is your escape. And this brilliantly illustrates how the Peel framework, point, evidence, explanation, link, maps perfectly onto computer science. Step 1, identify the exact requirement. That's your point. Step 2, classify the relevant element. Is it data, hardware, or software? That's your evidence. Step 3, explain the sequence clearly. That's your explanation. And step 4, connect it back to the context. That is your link. I want you to look at the screen and take a mental 30-second timer. Think about how you answered your last past paper. Did you follow Peel? This specific path prevents you from just word vomiting everything you know onto the page without direction. It forces you to construct a logical, bulletproof argument. Diagnosing the exam demand correctly is always step 1 of that framework. You need to look at the command words like evaluate, describe, or explain, and figure out exactly what the binary overflow question is testing from this list before your pen even hits the paper. Are they asking for a process explanation, a hardware selection, pure binary manipulation, or maybe logical reasoning about why a specific network protocol failed due to an overflow? Diagnosing the demand means you give the examiner exactly what they have on their rigid grading rubric rather than guessing in the dark. Let's shift our focus to Section 3, context over memorization. In the arena of Cambridge computer science exams, context is absolutely king. Let's look at a live transformation. On the left, we have generic theory, rote memorization, naming a method without explaining how it works, and dropping technical buzzwords. This is exactly what our student Sam did, rushing through and writing "use a bigger register" to solve an overflow. On the right, we have contextual application, anchoring your explanation directly to the provided details and scenarios in the prompt. If we take Sam's answer and rewrite it using our computer science success blueprint, it transforms. The red pen marks become green check marks. We change it to prevent the overflow error in the robotic arm's 8-bit sensor, a 16-bit register must be allocated, allowing the system to handle values greater than 255 without crashing. Do you see the difference? Students constantly lose marks by giving an advantage with no supporting reason or describing a technology that only sounds related, completely missing the contextual anchor. To really lock this in, let's rapid fire through the real-world contexts that examiners love to use. Smartphones and websites, school and office networks, industrial control and robotics, banking and retail systems, secure communication. Binary overflow isn't just an abstract chalkboard concept, it happens in literally all of these systems. If an automated robotic arm miscalculates its precise physical position due to a binary overflow error, that's not just a math mistake, that's a massive, dangerous physical problem. Linking your binary concepts to these specific, tangible scenarios helps you remember the why. It reminds you of the real-world consequences of these digital errors. And explaining those consequences is exactly what secures full marks.
We are now entering Section 4, Principal Examiner Warnings. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the minds of the graders and look at the red flags you must avoid.
Welcome to our interactive workshop segment. Examiners see the exact same red flags year after year. What's fascinating is that mistakes frequently arise not out of complete ignorance, but because students confuse nearby concepts. Look at the data on the screen for our first challenge. I'm going to give you a virtual 60-second timer in your head. Scan this data. The core trend is that students lose points mixing up memory versus storage, protocol versus service, compiler versus interpreter. When you are taking your dense revision notes, you must train yourself to compare terms, not just to find them in a vacuum. If you can clearly articulate the distinct difference between two closely related concepts, you become completely immune to the examiner's trickiest comparison questions. Moving to our next challenge, finding the flaw. I want you to act as the examiner. If a student writes, "A router is used for networks," which is an advantage, which of these errors are they making? Exactly. They are naming a device without explaining it and giving an advantage with no reason. As your strategic exam coach, I'm letting you in on the ultimate grading rubric secrets. These are the 5 most common errors: vague wording, missing critical steps in a process sequence, failing to answer in the context of the question, naming a device without actually explaining how it functions, and giving an advantage without providing the underlying technical reason. For our final challenge, you have 30 seconds to speed write one perfect Peel paragraph in your head that avoids all 5 of these traps. If you eliminate these habits, your grades will literally skyrocket overnight. So, how do we train for this? You implement the 3-pass revision cycle. Pass 1, secure your key definitions and, crucially, your contrasts. Pass 2, rehearse worked explanations and diagrams. Actually draw the binary additions out and write down the step-by-step logic. Pass 3, adapt to new exam scenarios. This layered revision style is absolutely vital because Cambridge questions love to combine pure theory with applied reasoning. You can't just memorize the textbook cover to cover. You have to adapt your knowledge on the fly to whatever bizarre scenario they throw at you. Which brings us to our final section, the 4-prompt checklist. This is the ultimate system to structure your memory and guarantee top marks. Here is your cheat sheet recap, bringing your mark potential all the way to 100%. This is your fail-safe memory structure and your final quality control check before you submit any answer. Combine this with the 3 rules that guarantee top marks: command word decoding, Peel framework application, and your time management matrix. I urge you to use these 4 prompts aloud when you study. 1. What is it? 2. How does it work? 3. Where is it used? 4. Why is it better or worse than an alternative? If you stumble on any of these for a topic like binary overflow, if you can't articulate why it's a problem or where it's specifically used in a system, don't leave it to chance. Rebuild your understanding from a worked example. So I leave you with this provocative question to ponder. Can you adapt your binary knowledge to any digital scenario the examiner throws at you? Remember,
The core strategy we've explored today is contextual application. It's not just about the ones and zeros, it's about what those ones and zeros actually do in the real world. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.